Today we're reviewing quadratic application problems. We're going to start with max or min problems. So if a problem is looking for the maximum or minimum value of a function, we want to always start by finding the vertex. The vertex in standard form is going to be negative b over 2a, comma f of negative b over 2a. And that's just saying once you find your x, that negative b over 2a, go ahead and find your y by substituting your x back into your function. The vertex is also the halfway point between the two zeros. So for example, if we have our graph here, and we have our quadratic, let's say this is 0, 0, this is 6, 0. Your vertex lives in halfway between those two. So all you have to do is average your x values together. So 0 plus 6 divided by 2. So that would give you 3, comma, f of 3, right? So whatever you found your y once you substituted f back in. So those are two different ways to easily and quickly find your vertex. If we are looking at non-max and min problems, so if a problem is looking for anything other than the maximum or minimum value, we want to substitute that number in for the indicated variable. If the value given is the input value or the x value, we want to solve by evaluating one side of the equation following order of operations. If the value given is the output value or the y value, we want to set the equation to 0 and solve by factoring, completing the square, or quadratic formula. One of the most often things you'll see when setting equal to 0 is where the ball hits the ground. So when you're asked at what amount of time does the ball hit the ground, so that is where your height is 0. So that's one of the most common ones that we see. So some key reminders: sketch a picture of the situation, define all the variables being used, and answer in a complete sentence. So let's go ahead and look at this first example. So Steve has 130 feet of fence to make a rectangular kennel for his dogs. He will use his house as one side. We want to find the maximum area of the dog kennel. So already seeing that it says maximum, I'm going to have to find a vertex. First, I need to actually write the function. So first thing I'm going to do is draw Steve's house. This is where Steve lives. So Steve is going to have a kennel off the side of his house, and it's rectangular. And it's using the fourth side as Steve's house. So it's going to look something like this. Anytime you do this, I would always say whatever your two congruent sides are, let those be x. So I'm going to let x equal the length of the side perpendicular to the house. So knowing that I have 130 feet of fence, I've used x on this side, x on this side. What is left for this third side is just going to be 130 minus 2x. So now we have to let a equal the area, right, because we want to find the maximum area. Remember, to find area, we're saying length times width. So I'm going to set up my equation as area of x equals length is x times our width 130 minus 2x. So let's go ahead and get this into a more standard form. So we have 130x minus 2x squared. So now we can go ahead and find our vertex by saying x equals negative b, so 130 is our b because it's with our linear term, over 2 times a, so a is negative 2. So x is just going to be equal to 32.5. So 32.5 is this length. Now we have to find that third side. So by substituting in 32.5, so we're saying 130 minus 2 times 32.5. So we get 130 minus 65, so that just equals 65. To find the area, we're going to go ahead and multiply those two together. So we're saying 32.5 times 65. So our area here is just going to be 2,112.5 feet squared. I need to write that as a complete sentence. So the maximum area is 2,112.5. Okay, let's go ahead and look at the next one. So the next one is a revenue problem. A store sells about 40 video game systems each month when it charges $200 per system. For each $10 increase in price, about one less system per month is sold. At what price should the store sell the video game systems to maximize the revenue? So I'm going to go ahead and I'm going to let x equal, we want that to be the thing that is changing. So we have the $10 increase in price. So we're going to let x equal the number of $10 increases. Then I'm going to let r equal our revenue. So when we're doing this, something we need to remember is that the revenue is equal to the number of systems sold times the price that we're selling them for. So we'll have the revenue of x is equal to, so how many systems are we selling? We're selling 40 systems and we're losing one system per $10 increase, so 40 minus x. How much are we selling them for? $200 plus $10 times the number of increases, so 10x. Now we want to go ahead and find our zeros of this function, because instead of multiplying all this out, we already have it factored, so it's easiest just to find your zeros and then average our zeros. So I would say 40 minus x equals 0, or 200 plus 10x equals 0. So here I end up with x equal to 40, or gives me 200 equals negative 10x, so x equals negative 20. So these are my zeros of my function. So to find the vertex, all I'm going to do is average these two together. So over here, we get x equals 40 plus negative 20 over 2. So that gives me 20 divided by 2, which is just equal to 10. So what this tells me is that I should increase by $10 10 times, and that's going to give me the most amount of revenue. So if I increase by $10 10 times, I'm increasing by $100, right? So we're saying 200 plus 10 times 10, 200 plus 100, so that equals 300. So we should be selling each game console for $300. Okay, let's look at our last one. It's a multi-part one. So a baseball player hits a high pop-up with an initial upward velocity of 30 meters per second, 1.4 meters above the ground. The height, h of t, of the ball in meters, t seconds after being hit, is modeled by h of t equals negative 4.9 t squared plus 30t plus 1.4. So all that background information is just to say that this h of t is our equation. So when it asks for us for how high the ball is after 5 seconds, we're replacing our t with 5. So we'll just say h of 5, so time is 5 seconds, equals negative 4.9 times 5 squared plus 30 times 5 plus 1.4. So this gives me negative 4.9 times 25 plus 150 plus 1.4. Negative 4.9 times 25 gives me negative 122.5 plus 151.4. So I get 28.9. So what this tells me is that after 5 seconds, the ball is 28.9 meters high. So now we want to see how long does it take the ball to reach its maximum height. So anytime we're asked to find maximum, we're just looking to find the vertex. So we'll say t equals negative b over 2 times a. So t equals, so negative b, so negative 30 over 2 times a is negative 4.9. So this ends up giving us t equals negative 30 over negative 9.8. So t equals 3.06 approximately. So what this means is that the ball reaches its maximum height after 3.06 seconds. So let's go ahead and look at C. So now we want to know what the maximum height of the ball is. So it reaches that maximum height after 3.06 seconds. So now all we have to do is substitute in 3.06 for t. So say the height at 3.06 seconds is equal to negative 4.9 times 3.06 squared plus 30 times 3.06 plus 1.4. This gives me negative 4.9 times 9.3636 plus 91.8 plus 1.4. We multiply and we get negative 45.88 plus 93.2. So we end up with a height of 47.32 meters. So what this means is that the maximum height of the ball is 47.32 meters. Okay, and now we want to know how long the ball is in the air before it hits the ground, or after how long does the ball hit the ground. So this is where we need to set h of t equal to 0, because we want where the height is 0. If we're looking at this ball being being hit, right? So here's your little batter, right? So they hit a pop-up. We want to know here how long it takes to hit the ground. So this is where you'll have the time is your t, comma, 0, right? Where your height is 0. So I'm going to go ahead and set negative 4.9 t squared plus 30t plus 1.4 equal to 0. And so we don't have to deal with decimals throughout this whole thing. Let's go ahead and multiply this whole thing by 10. That'll allow us to get rid of the decimals. So I have negative 49t squared plus 300t plus 14 equals 0. So I know that's not factorable, and even if it was, it looks pretty yucky to factor. So let's go ahead and solve using quadratic formula. So I have x equals negative b, so negative 300 plus or minus the square root of b squared minus 4 times a times c all over 2 times a negative 49. So now we'll just do our quadratic formula to solve. So we get x equals negative 300 plus or minus 300 squared gives us 90,000 plus negative 4 times negative 49 times 14 gives us plus 2,744 over negative 98. We get x equals negative 300 plus or minus the square root of 92,744 all over negative 98. So we take that square root, and it gives us approximately 304.54 all over negative 98. So now we're going to go ahead and just separate these into the plus or minus. So I'm saying negative 300 plus 304.54. That'll give me 4.54 over negative 98, or negative 300 minus 304.54 gives me negative 604.54 over negative 98. So this first one ends up giving me x equals negative 0.04, or x equals 6.17. So x equals 6.17 is going to be our answer. We can't have negative amount of time. So this tells me that the ball is in the air for approximately 6.17 seconds before it hits the ground. So anytime you're looking to find where something hits the ground, you're setting that height of time, h of t, equal to 0.